programming. Got really excited about the potential of functional programming for changing the way that companies build software. And after founding 2 companies built on functional programming, Precog and then Slam Data, I started doing a lot of contributions to open source that led me down the path to creating ZIO. And I'm really excited about ZIO. ZIO is a way of using functional programming to solve the problems that developers have around building async concurrent modern applications. And now, as a result of the success and traction that I've seen around ZIO, I founded a company, my 3rd company, SciVerage. And SciVerage is there to help provide training and consulting around companies that decide to go down the path of using functional programming to solve the challenges that they have. And I'm very excited to be here. Thank you for the invite. I admire what Software Mill has done for year after year in just sort of bringing the Scala community together and building great open source software, hosting Scala times, and continuously blogging about all things Scala. It's just been amazing to see how much good Software Mill has done over the years.
Thank you, John. Yeah, we are too very excited about the development of functional programming in the Scala world. And I really like especially the phrase that you used somewhere that ZIO is stealth FP.
Ah,
is that right?
Yes. Yes. I like that phrase too.
Can you tell us more about it? Why is it a stealth FP, and what do you specifically want to achieve with this?
Right. So I think that for a while, a lot of developers like myself, we encountered functional programming and we thought, wow, this is amazing. Why aren't more people doing functional programming? Because it changes the way you think about building software. It changes the way that you test. It changes just how much you're able to leverage the power of your compiler to check things at compile time versus runtime later on. It changes all that, and it makes us much happier and more productive as developers. So we're sitting around and wondering, if functional programming is so great, why isn't everyone using FP? And then the answer that a lot of us, myself included, had was, well, they don't know about it. You know, if only there were more blog posts that explained what monads were, then the whole world would be adopting FP. And so we went into the problem with a hammer and pounded away at FP education. And in the end, it does make some difference. Obviously, we need good educational resources, but a lot of developers are not sold on that approach. And that's because I think functional programming is about investing into yourself. It's investing into a new way of building software programs that helps you a lot personally, but doesn't necessarily help you get the next job or help you get a raise. It's not tied to anything practical like that. So I think the idea behind Stealth FP is that instead of educating developers into functional programming, we'll build really great libraries that solve problems that a lot of people have, and people will come to those libraries because they enable them to get more done for the business. They end up looking better, their projects have higher success rates, companies choose to adopt these technologies more, and as a result, functional programming becomes successful because of the value that it delivers to the business, not because of the value it delivers to someone as an individual software developer looking for a better mental model of how to put together programs. So Stealth FP is basically build great software that happens to use functional programming.
Yeah, I often hear this argument from developers that fine, it is actually very elegant to model software using FP, and many developers really appreciate working with such a model. But how can I convince the manager, the business people, that this actually brings more value, and that my need for education and for training the whole team in shifting the way we think, actually, because FP is, I believe, just a paradigm shift in the way we think about software. How can I convince the business people that this is worth investing in? So your one answer to it would be to try ZIO, and maybe there are some other arguments that we can use.
Yeah, so I think over time I've gotten better at identifying what it is about functional programming that helps the business. And so I think that there's a way that you can talk about functional programming that's going to connect more to business people, as well as developers who don't get FP yet. I think that's important. And then I also think just building great software, like building great software. Wouldn't it be awesome if someday a manager came to you and said, you need to be using ZIO? Like, clearly, like all these companies out here using ZIO can't all be that bad. Go out there and learn ZIO. And yes, we're going to pay for you to get training. We're going to pay for you to learn functional programming because that's apparently what you need in order to get your job done using this really great FP library. That's what I would like to have happen. Is instead of like FP is all bottom up now. It's all developers who love FP, evangelizing it and teaching other developers. But I think as we start building software applications and libraries and frameworks that solve deep pains across multiple areas in backend development and analytics and distributed development, then it's going to eventually lead to the point where it's your manager saying, you've got to learn this. It's top down, because whenever you solve business problems, then things come top down. Like you didn't have to convince your manager to use Spark, right? The companies were out there hiring Spark developers because Spark solved the problem that they had. And that's, I think, the idea behind Stealth FP is solve problems that the business has and then rely on that incentive structure to result in people learning about functional programming.
Yeah, so now in the world of libraries, for Scala especially, allowing you to do functional programming, there are some common pains that you quite often identify on your blog. In your blog posts, you mentioned some of the most painful points in doing functional programming. Some of them are maybe quite difficult abstractions to understand.
Yeah.
So that's why you built a glossary of functional programming on your blog recently, right?
That's right.
So these terms are one argument that I quite often hear in the beginning, that people say, I don't want semi-groups in my business code. That's mixing concerns. I want to show this to maybe some analytics, some people who are not necessarily developers, and I don't want to scare them with category theory terms. I believe that ZIO is a way that you can hide some of these weird abstractions from the code base.
Yeah, that's right. I think one of the things that I've come to appreciate over time is that domain-specific jargon is incredibly useful for the set of people who are deep in that domain. And they use it all the time. They need jargon because it helps them communicate efficiently and precisely. It's like doctors, for example, and lawyers, and hardware engineers, and every single different domain out there you look at, they have domain-specific jargon, and it's not accessible to the public. Like abbreviations, acronyms, just weird, esoteric, Latin in the case of the medical profession, and it's not accessible at all, but it helps them communicate efficiently and precisely. On the other hand, what we need in my opinion, what we need in functional programming is not people who already know functional programming to communicate more efficiently and precisely. We need a way to get more people on board the functional programming train. And to do that, I think one of the things that we can do that doesn't sacrifice any principles, but it can make functional programming more accessible for newcomers, is drop some of the jargon. That doesn't necessarily mean we drop abstraction or any of that other stuff, but it does mean when we're dealing with concrete data types, we can adopt jargon that's specialized to that domain. And ZIO does that all the time. So instead of calling, for example, an operation product that takes two functors and combines them together to give you, it takes a product of functors and gives you a functor of a product. So instead of having any operation like that, which is more like category theory, it has an operation called zip that takes two effects and zips together those effects into one effect that gives you a tuple. And even that simple naming change from product to zip, it gets a lot of people on the same wavelength and is much more accessible. It gets them to believe that maybe this isn't so hard, because honestly, none of the concepts in FP are that hard, but the jargon is unfamiliar. You have to learn new ways of thinking about coding. And if you can get people over that hump, and you could say, oh, it's not so bad to take two effects and zip it, two futures and zip them together to get back a tuple of what each one produces, then you can make it accessible to a whole new audience. And I think that what ZIO has done is demonstrate that if you pay attention to accessibility and ergonomics, then you can attract a larger audience in a smaller amount of time. And I think that's a real great learning for the functional programming community that can be repeated across all different libraries, across every domain, even across functional programming libraries like CATS and Scala Z. We can be learning from this and taking this into the next generation of software that we build.
That's right. I think another example of what you just described is that you renamed the pure function in ZIO to successful or something like that recently.
Yes.
Is that right?
Yes. Right. So instead of having pure or point, which again come from category theory, they're very esoteric terms, it has succeed. So ZIO.succeed is how you take a value and turn it into an effect that succeeds with that value. And succeed is just very domain specific. It wouldn't necessarily make sense for all functors. It wouldn't make sense for everything out there, but it does make sense for effects. And adopting that sort of, domain specific specialized jargon that has nothing to do with category theory can make it more accessible. It's future.successful, ZIO.succeed, that idea that you just want to take a value and return an effect that succeeds with that value.
Haven't you been accused of heresy when you
yes.
announced that?
Yes. And actually, that's not the worst one. The worst one was traverse. So in ZIO, there is no traverse, but there is this operation called for each. And this operation called for each lets you iterate over a bunch of elements and perform an effect for every one. So it's literally it's a for loop that's effectful. And then it collects back the results together in a collection if you need the results. But that is a hugely controversial change that was even controversial among all the ZIO users who already knew functional programming, because that's traverse. And everyone wanted to call it traverse, and we didn't call it traverse. And I think actually that decision, even though it was controversial, it actually helps us, because people who've never seen any FP, they don't know what traverse is. They have no idea. And why is that operation even called traverse? It doesn't even make sense why it's called traverse. But for each, they've used a for each loop. And the difference between Scala's for each and ZIO's for each is just whether or not you return effects from inside the body of the for loop. And in ZIO's case, you do. So I think that's an example of a decision that no one wants you to make. That is, no one who is vocal about it wants you to make. But if you make it, then suddenly adoption improves. And that's the kind of decision that I think more library authors need to make. These are painful decisions, because when you make them, you'll be attacked. But if you make them, then adoption of your library will grow.
Yeah, let's see how it unfolds, the reactions of people. But another thing in FP is that many hardcore FP fans like to code against very abstract types, right? The one example of this is using the MTL style or final tagless style, where everything is encoded with just an F with given constraints, or a better word than constraints, maybe capabilities expressed as type classes. And I remember that I read your blog about that being actually not very effective approach. Can you elaborate more on this?
Right. So I think that for every technique in FP, you have to very carefully weigh the benefits against the cost. I think that it's too easy in functional programming to deny that things have cost, or to assert without evidence that any small benefit in parametric reasoning or testability or purity is worth any amount of cost. And this is the case with final tagless, in my opinion. So final tagless is this way of abstracting over the effect type that your methods are returning and using type classes to regain the structure necessary to solve a given problem. And if you look very, very carefully at final tagless, then what you have are the following benefits. First off, in theory, you obtain the benefit of testability. In practice, it doesn't work out all that often. I've not seen that in real life code bases because these real life code bases use type classes like cats effect sync and concurrent effect and all these other ones that don't give you any testability. So but in theory, it could be a benefit of that approach is testability. And then you also gain indirection. So indirection means you can choose to work with cat's IO later, or you can choose to work with Monix later, or choose to work with ZIO effect later. So your choice doesn't necessarily have to lock you into a concrete effect type. If you want to sort of take a wait and see attitude and see if one of these things ends up as the winner, you can do that and then not have to change your code down the road. And then finally, the often touted benefit of Tagless Final is that it gives you something called effect parametric reasoning. And in effect parametric reasoning, you're supposed to be able to look at a method signature and then determine the set of capabilities that it is capable of using from inside the method without examining the method implementation. And of all these benefits, I actually think that it's the last one that is the weakest, by which I mean those guarantees are actually quite weak, given that Scala doesn't track side effects and you can perform side effects anywhere. And also given that most of the type classes used by Tagless Final programmers have no laws. They're just method signatures that can do anything. So your ability to understand what they do at runtime is extraordinarily low. And simultaneously, it has the highest cost in terms of pedagogy. How much time do you have to spend teaching someone all these concepts in order to get them up to speed? And how much overhead does it have in day-to-day usage? How many characters do you have to type? How many error messages do you have to struggle with? What are the effects on discoverability and so forth by using this approach? And in my opinion, it's just for the vast majority of teams, Tagless Final is not worth it because that final bucket, it's just the benefits aren't there. Return on investment is not there.
I see. So you think that it's a better approach, for example, when you're writing libraries, not necessarily applications?
So I think if you're writing libraries, then there is a more compelling reason to use Tagless Final, because that way you as a library author can support the ZIO.
Okay, sorry, I think we lost connection with John.
Now that said, yes, I'm back.
Sorry, John, you're back?
Yes.
Okay.
We got disconnected, I think.
I think we're fine now. Sorry.
Yeah, no worries. So library authors, I think there can be a reason to, if not use Tagless Final, then use some means that allows you that level of indirection. But also with indirection, there are associated costs with indirection. So anytime you are providing a layer around all the different effects, you're necessarily coding to the lowest common denominator. And what I've seen in the ZIO ecosystem is that matters a lot because the lowest common denominator between all these different effect types is actually fairly low. You can't assume a lot of capabilities. And so what is happening in the ZIO ecosystem is ZIO specific sort of ZIO native software is being written because end ZIO users want to leverage the capabilities that only ZIO has. So you have to be careful. Like if you as a library author want to take the stance, hey, I don't want to commit, I want to stand back and support everyone, you may find yourself in a position where you're forced to have that lowest common denominator, which is okay for sort of middling use cases, but then anyone who has a specific effect type, like if you have Monix, you're going to look for a Monix library. If you have ZIO, you're going to look for a ZIO library. You could be in a situation where, yeah, you support the whole world, but because you're so bland and generic, no one who has a specific library wants to use your solution.
Right. So you propose that maybe instead of doing final tagless, people just use ZIO directly as the type returned by the functions.
Well, I think for library developers, or rather for application developers, in my opinion, the vast majority of teams, not every single team, but the vast majority of teams will be way more productive, and they're going to have way easier time hiring new developers if they use a concrete effect type. It doesn't have to be ZIO, it could be CatZIO, or it could be Monix, or it could be ZIO. But if they use a concrete effect type, that code will survive longer. That team will grow faster. People will ramp up more quickly, and the developers will have a much more enjoyable, pleasurable experience coding because they don't have all these layers of ceremony that are not really paying for themselves. And I think there are exceptions. There are a few teams out there who are happier, more productive using Tagless Final. But I think for the vast majority of cases, using a concrete effect type, no matter what it is going to improve just everything.
Yeah, but isn't using concrete type going to put us in the situation that you mentioned, that there is no parametric reasoning, right? I think that's the name you used. You cannot reason about what actually are the constraints or the capabilities. It's just ZIO, so it can do anything. You can call arbitrary side effects or synchronous code, blocking code, right? It's just ZIO of something.
So the interesting thing about that, though, is that first off, the type classes being used in Tagless Final have no laws. They're just bags of method names that can do anything they want. And it's not like they're going to break a law. So you can't actually look at a type class like logging or console or user repo and know what it's going to do. You can't know anything about it. They may be blocking, they may be async, they may be, who knows exactly what they're doing. There's no way to limit what those things do by looking at the type signature. So you're just calling a name method that does something and gives you an int. You have no idea what it does or how to use that in a generic fashion. So the benefits of generic reasoning don't apply to type classes that have no laws. And by and large, people are using type classes that have no laws with Final Tagless. And then beyond that, first off, the benefits only apply up to discipline. And what I mean by that is you cannot perform any side effects inside any method that is using Tagless Final. And in reality, it takes an extraordinarily disciplined and senior team in order to do that. I've looked at so many code bases where people perform side effects inside of calling map, inside of calling flat map. They call some Java method that was side effecting, and they're just calling it inside applicative point or whatever it is. In reality, these code bases are only going to be good and only going to permit a useful form of reasoning if the developers who are maintaining them are extremely diligent about code review and check line by line to make sure that no one is doing any side effects in the wrong places. And if you had a team like that, then they can make it work with whatever technique they want. For example, in a ZIO code base or in any specialized, IO or Monix, whatever code base, they could make sure that developers only interact with the external world through interfaces. That is, in every class inside the constructor, any interaction with the external world is going to come through an interface. So they can achieve the testability and reasoning benefits they want without Tagless Final merely by using sort of brute force discipline. So Tagless Final, because it relies on discipline, and because you can't reason in any way about type classes that have no laws, in my opinion, effect parametric reasoning is, the benefits you get from that are almost non-existent. You can do very limited things by, for example, looking at code that requires functor versus monad versus applicative, but that's a parlor trick. It's not actually useful when working on real-world software applications.
I see. And I would like to ask you, maybe you have some more experience than me with other technologies than Scala. Have you ever seen functional applications written in a functional style in other technologies like Haskell, for example, to compare if the problem is common among technologies, or is it Scala specific?
I think that in Haskell, it's easier to have effect parametric reasoning, but I would still say the majority of developers in Haskell writing commercial applications don't use Tagless Final. Like Scala's functional programming community has an unnatural obsession with Tagless Final at the moment. I don't think that that's pervasive. It's certainly not pervasive in Haskell. Like a lot of real world production code doesn't use Tagless Final. And then PureScript has its own approach. There's a lot of monomorphic code out there using AF, which is an asynchronous effect system. There is no type class to describe AF. There's the standard type classes like Monad and whatnot, and that's used to write some generic code. But lots of end user applications are just written in straight up AF. And then other programming languages, they don't really support or encourage that distinction because they don't have higher kind of types. So in OCaml or ReasonML or any of these other functional programming languages, you're not even coding in that style.
I see. So, okay, let's say we have a service in our company that's actually an actual case. I'm working a project right now, and I'm considering trying out ZIO, for example. What's the best way to introduce ZIO to an existing project without too much, intervention?
Yeah, so ZIO supports the cats effect type classes, which means that in any application that uses Tagless Final or cats effect, you can just sort of slip ZIO in as an alternate implementation of those type classes. And that means ZIO works well with all the libraries out there like HTTP4S and Doobie and FS2 and so forth. However, I think you're going to get some benefits from that. Primarily, you're going to get the ability to do execution traces and fiber dumps and those sorts of operational benefits. But you won't experience ergonomic benefits, or like ZIO has lots of operators that have different semantics or that don't exist in the cats effect type classes. So you won't get the benefits from using that. Honestly, I don't think that there's, unless you have place a super high premium on using the execution traces or the fiber dumps, I think that probably just swapping in one effect type with another, but interacting with it in the same way through the cats effect type classes, you're probably not going to see a day-to-day difference in that. It's, if you're using the same API, if you're subject to the same limitations of a monofunctor effect type, then I think that there's not a gigantic difference between them.
Okay, so I can just switch my F to be, choose my F to be ZIO, and this should work.
Right. It should work,
good.
But then why would you want to do that? It's like, I always tell people, if they're happy with what they're using now, if they don't have any pains, then they should probably just stick with it. Like, this always chasing the new thing is not necessarily useful for your code base or your clients or customers. It's like, we learn a lot when we use new technologies, but ultimately we have to weigh that benefit of personal learning against the very real cost of impacting the code base in a significant way. And if you're using one of the other effect types and it's working, then I would say, why ZIO? I obviously believe in ZIO, but also I'm aware of the fact that it solves pain points that not everyone has.
I see. I know that one pain point addressed by ZIO is the way dependencies are built, usually in functional programs using the reader monad. And ZIO identified this, that it can be actually included in the type of ZIO itself, like the environment type, right?
Yeah.
And I heard voices that it's a big game changer, the recent update, the Z layers introduced to ZIO. Do you have some more feedback on it? What do you think about it?
Yeah, I think, first off, I've always been a big fan of ZIO Environments because it allows you to achieve the benefit of testability, which was the #1 selling point of Tagless Final, in my opinion. It's testability. It allowed you to achieve that without any of the ceremony or boilerplate or pedagogy of Tagless Final. So it radically lowers the barrier of entry to getting testability out of an effect system. Now, that said, prior to the recent release, you had to use almost this cake-like pattern in order to glue together parts of an environment. And there's a certain amount of boilerplate that comes with that, because those are operators that don't exist at the value level. You can't take two classes. There's no operator that lets you take two objects and combine them together into another object that has the methods of both. If there were, then there would be no problem with that sort of mini cake pattern that ZIO Environments encouraged people to adopt. But given the fact that those are not values and there are no value level operators to do those things, what happened is that it was great using ZIO out of the box with the services that it provided for like clock and system and so forth. But then every time you went to create your own environment, or you created your own environment, you had several different things going on there, and then you're using third-party ZIO libraries and they have their own thing, then more and more ceremony and boilerplate was involved in constructing something that would satisfy the types of the Scala compiler. And lots of proxying, lots of delegation, lots of manual type annotations. It was very painful, and I think it put a lot of people off of the practical benefits of ZIO environment. And then also we had a related problem, which was you couldn't easily modify a part of the environment. So for example, if you wanted to take a random or like a clock interface and modify it locally so that it would do something differently, you couldn't really easily do that. You couldn't do that at all in a generic fashion. And all of these drawbacks, they combined together to mean that even though ZIO environment was very promising, things just didn't fit together perfectly. And there was enough overhead in using ZIO environments that I could understand why some people wouldn't want to use it. And then what we recently released was something called ZLayer, and ZLayer solves all the problems with ZIO environment. So it allows you to snap together big environments out of small environments using value level operators that can work polymorphically. It allows you to locally modify services. Like if you want to turn this service off here or proxy it or decorate it in some fashion, you can do that very simply. And then it also provides this mini language allowing you to construct a dependency graph for an application using two operators, one that feeds some services into another set of services, and then one that just sort of bundles them both up together so you can use both of them in an application. And the feedback from that has been amazing. It addresses all the #1 pain points, I would say, with ZIO environment. And also what it allows every library author to do is export a layer. These things are called layers. Export a layer, and then as an end user, you can just snap all these layers together. So you have the ultimate flexibility, plug and play sort of compatibility to build your dependencies up in a very natural fashion with good type inference and without any of the boilerplate common in ZIO environment. So I do believe it's a game changer. I don't think it's necessarily the ultimate answer to dependency injection. That problem has been with us for a long time, and there's not really one solution that can fit all needs. But I do think it's very interesting, and I think that probably if you fast forward 6 months or a year from now, the vast majority of ZIO users and ZIO libraries will be using ZLayer.
I see. So the dependencies that are included in ZLayers, do you recommend it to be rather technical dependencies, like layers exported by libraries or layers representing some, let's say, technical infrastructure layers, or also services, like everything should be put there, in your opinion?
Everything okay. Should be put there, in my opinion, because the way to think of a layer is it's a better version of a constructor. That's all it is if you could take a constructor and turn it into a value and then make it so that a constructor could produce not just one service, but multiple services, and then you gave it two operators that would allow you to compose these things together, then you have something that's extraordinarily powerful. And right now we're building, if you're not using ZIO environment, you're building your application graph through constructors probably. If you're doing Scala, then you have a bunch of constructors. Every constructor requires its services and produces its own service. So the change to use ZLayer is small. You just take every constructor and then in the companion object, you put a layer that wraps that constructor. So it's a tiny little change, but then because you turn that constructor into a value, it lets you wire everything up in just an amazingly elegant way. So in my opinion, everything should be a ZLayer, whether it's infrastructure layer or sort of business service, it should be a ZLayer. If you're a ZIO user who's not using ZIO through Tagless Final, then it makes sense to go all in on ZLayer because the libraries are going all in as well. So right now, all the libraries are in this process of adopting ZLayer, which is making it very easy to snap together these dependency graphs. And I think that's just going to continue. And then feedback, early on, feedback was amazing. So many users wrote in the ZIO Discord, wow, they're like, this deleted hundreds of lines of code. ZLayer is the best thing ever. Those were the users who lived through the pain of ZIO environments pre-ZLayer, and they can see that it's just a a radical improvement on everything that we had before.
Yeah, and are there any other radical changes coming to ZIO soon? Because we are pre 1.0 right now. Is that true?
Yes, so pre 1.0, but we're super close. There's no radical changes. There's nothing left now, basically. We did everything we wanted to do. There's a little bit of polishing around the auto supervision model right now that's happening, but there's nothing else coming. And now, that said, when we ship 1.0, there'll be two parts of ZIO that aren't locked down, and that's the ZIO Stream API and the ZIO Test API. So those are two components. We'll probably try to lock ZIO Stream down in 1.1 and ZIO Test down around the same time, or maybe 1.2. But those are newer parts of ZIO that just needed to spend more time being used by people for us to figure out how the pieces should fit together properly. But we're slowly figuring that out, and we're going to have it done. Both of those, I think, will go gold, so to speak, before the end of the year.
I see. So one main pain point that you identified was the dependencies built with reader T. So no more reader T. We can use the environment and do it in a much more flexible way. And the other thing, I believe, is error handling, which was often dealt with using either T and the error type that is used within ZIO is a response to this subject, right?
Yeah, so either T, there's some problems with using either T. First off, it imposes performance overhead. So anytime you're using the either T monad transformer, then basically you have the either T data type sitting up here, and then inside there you have an F, where F is your effective choice, and then inside there you have the either data type. So you can eliminate the overhead of the outer one. So that's not a big deal. You cannot eliminate the overhead of the inner either that sits inside F. And not only that, but every time you call flat map or map or whatever on the either T, that involves additional lambda allocations, which end up being wrapped. So you get sort of wrapped lambdas. And then if you're interacting with all of this through type classes, as you would do in a tagless final application, then you have additional levels of indirection because you're going through not either T, you're not going through concrete methods in a concrete data type, you're going through instances, type class instances. So the JVM is not going to be able to see through that and inline anything. So you have all this overhead in the form of additional heap allocation, additional invoke virtual, and then additional megamorphism. And all these impose overhead. People who have used either T and compared it to ZIO say ZIO is 4 times faster. In some cases, it could be 10 times faster. So you have the performance overhead. That only matters, though, if you're using either T and performance critical code. If you're using it just at the edges of your application, you're probably not even going to see that. So even for those cases, though, either T has really horrible type inference. So because it is in these functional programming libraries, they decided not to really embrace declaration side variants. They went all out invariant. So these monad transformers generally tend to have really terrible type inference. They're a pain to use. You have to specify all the types everywhere. And that's not very fun. And then if you're using either T through a tagless final, then you're in even a worse situation. I mean, first off, some of the type inference issues maybe go away, but then you have other types of issues. Like, for example, you have the fact that monad air and applicative air and all these other type classes, they don't allow you to dynamically change the air type. So when you handle an air, you have no static guarantee that you've handled an air, even though in theory that's possible. These type classes simply weren't designed to expose that capability. So you have all these drawbacks that come from using either T. And in my opinion, the reality is that almost every single, you also have the additional drawback, which is that it is very hard to provide instances of some type classes on either T for the underlying effect type. It can be quite challenging to provide all of those. And the ZIO solution is, look, every effect type out there, they have to support airs. They all support airs. So instead of just fixing that air type to be throwable, like try does, why not allow it to be polymorphic, like either does? So that way, if you want it to always be throwable, you can have it always be throwable. But if you don't want it to be throwable always, you can substitute your own air type in there. And the biggest difference that I've seen is merely the difference between an effect that can fail and an effect that can't fail. So in ZIO, when you handle an error, you can see that in the type. The compiler knows you've handled the error. It can't fail now. Whereas when you handle an error over in one of the monofunctor effect types, you don't know you've handled the error. You have no static way to track the fact that you've just handled an exception or that you need to handle an exception maybe. And that makes a big difference in understanding the error behavior of your code. When I look at code written using monofunctor effect types, I have no idea what the error behavior is. I can't tell you where it's going to fail, where things could go wrong, where errors have been handled, and so forth. But when I look at the corresponding ZIO code, the compiler is telling you. It's keeping track of all that error information automatically. And I think that's a really simple, low-cost way of leveraging the Scala compiler to make sure that you can spec out your error behavior and reason about it statically.
I see. I would just interrupt for a second now to mention that we have a lot of people who joined us and listened to our conversation. And if there are any questions you would like John to answer regarding the subjects that we are discussing, please put them in the chat box. And if we have time later after the conversation, we'll come back to the questions and see how John can respond to them. So, and now coming back to the error type, if I understand correctly, ZIO has an instance of monad error, and this instance of monad error regards the error of the type in ZIO, of the error type in ZIO, right? So you can fail a ZIO only in one way, or like in other effects, because quite often people choose an effect like IO or future even, or some other effect, and it can fail. It has an instance of monad error, and additionally, in the result type wrapped by this effect, there is an either. That's why we get either T. So we have two levels of errors, often divided into technical errors, which are like failures, connection failures, database failures, used in the failures of the F, and business failures in either. And so ZIO addresses them both, or how does it approach it?
Right, because we're dealing with Scala and the JVM, we can't stop people from throwing exceptions. For example, someone can map over something, and instead of providing a pure function to do that transformation, they could provide a partial function, and that will result in a runtime error. So what ZIO does is it has a lossless error model. It actually uses a free semi-ring called cause to encode 100% of all information about errors. And the reason why that's necessary is because not only of things like throwing exceptions in map and flat map and other places, but it's also necessary because when you combine effects in parallel, then suddenly you could have parallel errors. Or if you fail in your primary code and you fail in a finalizer, in a finally block, then you could have multiple sequential errors. So cause is the data structure that allows us to capture all that. So that information is tracked by ZIO. It's still accessible. You can access it when you want to. You can do what's called sandboxing an event, which exposes, it takes that E, that error type parameter, and blows it up to be a cause of E, which allows you to see this full story. So if you want to be able to handle sequential errors, parallel errors, or defects in your code, which result from partial functions or just throwing exceptions in places you didn't anticipate, then you can use that sandboxing facility to handle those types of errors. And I think that achieves a very good compromise. First off, it allows you to have the so-called technical errors. Like in modern applications, in all applications, there are two classes of errors, and I call them recoverable errors and non-recoverable errors. And I think one of the interesting things is that, and like, don't be too eager to classify an error as non-recoverable. Like right now, if you're using an effect type, a monofunctor error effect type with either T, then most likely what's happening is you're using the throwable error channel to classify all things as technical errors, and then you use either T to classify everything else as a business error. Whereas using ZIO, you can basically say, okay, when you're opening this file, you can see in the type signature an IO exception. And then I can decide either at that point or later on that this error in the typed error channel should be treated as non-recoverable. And I can call or die, there's a combinator called or die on there to basically delete that and to treat that as a fatal error. and it doesn't interfere with your ability to sandbox it at a much higher place, but it does sort of take it out of the way and say, for all intent and purposes, my application can't continue if I got an IO exception here, so I'm going to go ahead and terminate. And that fluidity allows you to, as you're moving up the sort of application stack, to decide on a case-by-case basis whether a given error type is going to be recoverable or non-recoverable, because whether or not it is, it depends on where you are in the application and also the needs of the application. So in ZIO, we encourage people to use the typed error channel for errors that they want to recover from, whether those are technical errors or business errors, and to allow that to change as you're going up the stack. You know, get rid of the stuff that you can no longer handle and just let that be fatal error. And we also encourage people to sandbox effects at the edge of the application. So if you're building an HTTP endpoint or a microservice or something, sandbox the effect so you can see the full story of what happened, and you can translate that into a useful diagnostic error message for people who are calling into that code.
I see. So I have one more question regarding the capabilities of ZIO. This one comes from me personally, because recently I've been using a lot the functionality of Monix task, which is its local storage. Let's call it like this. It's nice for example, doing tracing. If you can refer to some local variables which are available between different Fs, different tasks, they are still managed by the scheduler, I believe. Somehow. Is there something similar in ZIO?
So ZIO has a fiber ref, which is the fiber version of a thread local, but it's actually more powerful than a thread local, because what happens is if you have a parent fiber and it forks a child fiber, so now you have a child fiber running, doing its own computation, it inherits the ref value from its parent. And then later on, if you join that child fiber, then its value of the fiber ref is combined into your own value of the fiber ref, so you don't lose any information. So basically, fiber refs, if you want to think of your application as defining a graph, every time you fork an effect, that sort of creates a new line in the graph, and then every time you join it, that removes a line from the graph. So these define fork join graphs. Your application is a fork join graph. Then fiber refs follow that fork join graph exactly. Whereas with thread locals, you don't have that same guarantee, because a different thread means its thread local resets. Even if you started that thread, even if you would like it to have your value, you can't really affect that. So I think it can be viewed as a better version of thread local that also combines associatively, which is a feature that Monix does not have.
Sounds good. And I remember your talk at Scala conference about the death of Akka. Of course, that was humorously, but you presented how ZIO can be used basically to build most of the patterns that people expect from Akka actors. That's why Akka actors don't seem to be really something really important now, because everything that you can model with Akka actors can be as well modeled with ZIO, and even in a safer way. And often people respond to that with questions like, okay, so how about Akka persistence or Akka clustering or Akka distributed data and all these additional modules, which are not necessarily focused on actors, but on completely different concerns. Are you planning to incorporate ZIO in these subjects? Because this, going to the world of clustering, I believe, requires a whole new set of tools, right?
Yes. So I think that absolutely ZIO has to move there, because there are a subset of applications right now that you cannot do with functional programming. You have to use technologies like Akka or similar in order to solve these problems. And even though you can do that from a nice way, for example, there's ZIO Akka cluster, which allows you to wrap that stuff in ZIO and use it in a nice, pretty FP package. I still think that FP has tools that we can bear on these problems that are going to result in solutions that are easier to reason about and easier operationally and easier to diagnose when things go wrong. And so I think two interesting projects in the ZIO ecosystem are ZIO Keeper, which is basically a membership and metadata layer, as well as consensus layer for distributed applications built on ZIO. and then ZIO Distributed, which is sort of the bigger long-term vision for providing a set of features that allow you to avoid Akka cluster. Actually, swap in something that is better in some ways than Akka clustering. Maybe it doesn't address exactly the same set of problems, but I think the combination of technologies in the ZIO ecosystem will negate the need to use Akka cluster in most cases. There'll still be the occasional place where maybe Akka cluster is a better fit, but I think that for the vast majority of cases, ZIO technologies will be a better fit, and they'll be built with an emphasis more on sort of algebraic properties, so algebraic reasoning, laws, principled design. So I'm really excited about those projects. There are ways off, I think, from being launched. ZIO Keeper, you can already play around with that. I also think that a lot of Akka cluster use cases can be done and are being done increasingly with Kafka. So any sort of work distribution, it makes sense to use Kafka these days in lieu of Akka cluster. There's still a subset of problems though that we can't directly address without Akka cluster, and those are the ones that ZIO cluster, or rather ZIO Distributed and ZIO Keeper are targeting.
So we have now many ZIO projects in the ecosystem, right? The community has grown to a large extent very quickly. It's a whole ecosystem.
Yeah.
What do you think about the community?
Oh, the community is amazing. It's just I've never seen a community quite like ZIO. It's just filled with tons of friendly people, and there's so much energy and a very can-do spirit. I think, like, people just interested in getting into all sorts of things, and also there's a lot of pay it forward. I see, like, in the early days, it was me trying to teach and mentor people and review pull requests, and then nowadays we have people like Adam Fraser and Itamar and Pierre, just so many people out there who are doing the same thing. They're like, come on, build some great software, and they review pull requests and they help level people up and absorb what you have to know in order to write really good functional Scala software. And so it's good to see that pay it forward attitude be a little contagious, I think, and it's responsible for some of the growth of the ecosystem. I also think it's a very friendly environment. It's just so many people chose to make their first open source contribution to a ZIO project, and that's amazing. There's a whole new generation of open source contributors and even speakers in the Scala system whose first project was a ZIO project. That's amazing. I'm really excited and happy and honored to be a part of that.
Yeah, I can confirm that. I personally joined the community and played myself with ZIO Kafka in particular, and the community is very welcoming. And I highly recommend people to join and try anything they want. Can you say to our listeners what's the best way if they would like to start with some maybe low-hanging fruits?
Yeah, so I think. Yeah, so the ZIO Discord is the place to be. There's hundreds of people on there, and they're very receptive and responsive. And we have a chat room for every different project. And the chat rooms generally tend to feature the leading contributors to the different projects. So go on there and find something that's interesting that could use a hand. There's lots of early stage ZIO projects like ZIO Keeper, ZIO Distributed, ZIO Redis that can use a hand. And then just say, hey, I want to work on something. Does anyone have something for me? And then if it's not myself, then someone else will they'll go out of their way, I think, to help you find a ticket that's a good fit and to help spec out that ticket and to help review your pull requests and make sure that things are being done according to standards. And then if all that fails, then you're welcome to reach out to me personally, and I try to get as many people started as I possibly can.
Sounds great. So now there is this large community around ZIO, and you have yourself created a company, SciVerage, around ZIO. Can you tell us a little bit more about what SciVerage is about?
Yeah, so SciVerage, I had been trying to figure out what I wanted to do next after taking some time off in between startups. And then SciVerage happened when I just started to see adoption of ZIO by corporations. Once I started to see how fast that was growing, I thought, well, most likely we need a company that can provide consulting and training and support and services around any company that decides to go down the path of solving business problems using functional programming. And that's what ZiVerage is really about. ZiVerage is here to help companies succeed using functional programming. And I think right now in the early days, that involves a lot of handholding. It involves, a few hours here, a few hours there. It involves training whole teams of developers. It involves a little sort of development and maybe open source work. And over time, I hope that we can find business problems that can be solved uniquely by functional programming that we might be able to build sort of some product around. That would be my goal, is right now, help companies succeed using functional programming, and then eventually, over the long run, help build products that are powered by functional programming that can help businesses solve business level pains.
I see. This sounds very interesting. And do you have any upcoming plans for workshops online or maybe some online conferences?
Yeah, so there's the Scholar Conference, which is online. That's upcoming, so I encourage everyone to go to that. LambdaConf is doing a weekly session, so every week at Tuesday at 3:30 to 4 or 3 or 4, somewhere in there, p.m. Eastern Standard Time, there's going to be a talk, and I'll be speaking there as well. I can't remember exactly when I'm speaking, but I'm going to be speaking there. And then what else is going on? Yeah, there's a lot. So there's just so much stuff happening online. You don't even have to leave your living room to be able to attend all these meetups happening, all the Scala meetups. I'm speaking at Scala in the city later this month with a bunch of other people. They're putting on an online conference. So if you like attending events and conferences, now's the time to do it, because everything is either cheap or free, and there's a ton of them that you can attend from your living room in your pajamas. It's a really good time to be interested in learning about Scala and functional programming.
That's right. And now you have also opportunity to ask questions to John. And I can see that we have a few. And so let me quickly look through them. I saw one interesting question that Willem Vermeer, if I spelled correctly, asks, it would be great to create microservices with 100% ZIO components. But now you need HTTP4S or akka HTTP for API, STTP for HTTP client, Doobie for JDBC, etc. What are the plans for 100% ZIO microservices?
So right now, if you're willing to use Google Protobuf, then you can use ZIO gRPC, which is a project that from IDL, so from your interface definition language, you can generate all the infrastructure necessary to work with ZIOFX and ZStreams. So that's a really good project made by the author of the leading library for Protobuf in Scala. So I encourage you to check out that if you want native ZIO microservices today. And then I think my own personal vision for ZIO HTTP is to come in and do something that's ZIO native, do it in a different way, and to make it very, very easy for people to create HTTP or otherwise microservices using ZIO technologies, and to what extent there's interop and or dependencies between that and other ecosystem libraries, I think remains to be seen. But the demand is definitely there. The demand is there. People want to see something in this space, and it's definitely going to happen. It's one of my top priorities, I would say, for the next 2 quarters.
Sounds interesting. And another question is, sorry, I'm trying to learn how to use this software actually. What's the future of ZIO with Scala 3? Because Scala 3, many people say it's around the corner. So I believe that ZIO is getting ready for it too.
Right, so I think one of the decisions that we made early on was to compile, cross-compile on Scala 3. It took a lot of effort to get to that point, and it still takes ongoing effort. But Scala, or ZIO, I think, is probably one of the first, maybe the first major Scala project to compile under Scala 3 and be usable. And also many of the features in ZIO, for example, our use of intersection types and our support for polymorphic errors, were designed with a view to Scala 3 in mind, because they become easier or better in some fundamental way with Scala 3. So I think the language or the library itself, it already works great in Scala 3. It's in the Scala 3 community build. Many people looking for Scala 3 software to play around with are playing around with ZIO. And in the future, it's only going to become better with Scala 3. So I think we'll be one of the earliest projects to like go Scala 3 native, in the sense that we port over all the code to Scala 3 style and syntax and start using Scala 3 specific features. And I think that we're going to use almost everything in Scala 3 to improve user experience in some way.
I see. And here's another interesting question. I'm not sure if you're familiar with Kotlin coroutines.
Yeah.
Maybe you can compare them to ZIO fibers.
Yeah, so I think that roughly they're going to be somewhat similar right now. I think that Kotlin has the benefit of having access to the AST of the source code, so it can do a lot more optimizations up front. And also it can allow you to program in a more straightforward procedural style, whereas ZIO requires that you program in a value-oriented way, for example, using for comprehensions or explicit operators on methods. So Kotlin is much more accessible to a much larger audience and has the ability to do some types of optimizations that ZIO can't, because it's a library implemented with all the constraints that go into being userland code. But that said, I think that ZIO has a tremendously superior model for concurrency, just because it's inspired by a long history of concurrent programming in FP, Haskell and STM, and just the async package, all the stuff out there that's been serving production Haskell developers for many years. We had the benefit of learning from that, and we're working with values, so we can adopt similar approaches to some of these same problems in ZIO. So I think even though Kotlin has some advantages in some respects, I think actually you can be more productive with ZIO. And I think actually there's a blog post that came out recently comparing a Kotlin solution with its ZIO equivalent, and the ZIO equivalent is 10 lines of code compared to a couple hundred lines of code. And that's the sort of productivity benefits that I would expect to see, even given the fact that absolutely, Kotlin, it's going to be faster in a straight up apples to apples comparison. And it's also going to be more familiar to developers because they don't have to learn a new way of writing their applications.
Okay. Another question by Jarosław Derman is, I'm not sure if it's a serious question, but do we really need ZIO Spring? Is ZIO Spring a thing, actually?
So this is, again, something that's probably going to be very controversial in the functional programming community, because Spring is bad. We all know Spring is horrible, and we like functional programming because it's not like Spring. But I think that there are some very positive aspects of Spring that are underappreciated. And an example is it allows a single developer to be enormously productive. A single developer can sit down and with Spring, if they've used Spring before, they can stand up a new application that has a bunch of endpoints, metrics, and monitoring and persistence and security and all that stuff. They can do that in an afternoon. And also, they don't have to know a lot in order to do that. They don't have to have deep knowledge. Superficial knowledge is enough to do that with Spring. Now, as we all know, Spring has a dark side as well. It's not composable, and it has lots of magic and lots of surprising edge cases, corner cases, and all of that's bad. But the basic goal of Spring, to enable someone to be extremely productive with superficial knowledge, is a good one. And I think that the functional programming community, more than anything else, they need something that's like Spring, in the sense that you should be able to take a new Scala developer or a Java developer and sit them down and have them be productive and crank out a new endpoint equipped with all these features sort of out of the box in a matter of a few hours. And I think we are at least one order of magnitude, maybe two orders of magnitude away from having a solution that enables that level of productivity on that level of superficial knowledge. That's what we need in Scala, in my opinion.
I see. And another interesting question is, will ZIO fibers benefit from JDK Project Loom? I'm not sure if you have checked the upcoming features of JDK.
Absolutely. Absolutely. So yeah, we're going to tremendously benefit from that, because it means that we can basically delete all the custom async code that's responsible for powering asynchronous callbacks in ZIO and replace that by Loom's continuation. So that's going to result in improved performance for async code without developers having to do anything. And also, interestingly, after all the sort of JDK libraries have been churned over to use fibers consistently, it's going to allow us to delete the distinction between blocking and non-blocking. So there will be no more blocking anymore. Everything will just be non-blocking, which will simplify the conceptual model. So ZIO will get faster and better as a result of Project Loom. But ZIO application developers won't have to change any of their code. You know, they'll be able to, basically ZIO allows you to gain the benefits of fibers now, but in a way that's future compatible.
I see. Sounds great, actually. I think that many libraries are waiting for this Project Loom to get benefits from it. Another question is regarding the future plans for ZIO IntelliJ. I saw that there is a plugin and it gets updates quite frequently. Do you know something about upcoming features and its development?
Yeah, so that library is done entirely in the part-time. It's not like supported or anything. It's done entirely part-time by Igal, HMemCopy, you might know him as on Twitter and GitHub and various other places. And he's done an amazing job with that, because the library, what it does is it gives you, basically it's like a helper, almost a mentor, who's telling you, hey, are you sure you want to do that? Maybe you should change this way. Maybe you should fix that into this. Maybe you should simplify using this type alias. It's like trying to be your best friend and ZIO guide. And it provides a way to run tests and do all sorts of other things. I think that actually has made me more excited than ever about IntelliJ IDEA. I've been a big Metals fan, but Metals doesn't have plugins, and they don't want to add plugins ever. So as far as I'm concerned, like, tooling can make a tremendous difference in people's productivity and in the accessibility of new technologies. There's great tooling for Spring in IntelliJ IDEA, and having the quality of tooling that Spring has, but over for the ZIO ecosystem and more focused around the needs of functional programming, would be an amazing. And I think that plugin is a good step in that direction. And I hope that we'll see a lot more development of that plugin and eventually get it to the point where you don't need to, basically you need to read docs less, because you have that guide, that friend there who's helping you get things right in your functional programming application that's written using ZIO.
I see. So it looks like we can say now that ZIO is maybe going to be the Spring for Scala, maybe, and we can call it already a framework. Or you
I think
really don't think so?
I think it's close to a library, but it does provide some framework-like things. Like ZLayer really is a method of dependency management, if not dependency injection. And it gives you a fabric on which to build applications. I don't think it's exactly Spring. I think what I'm looking for in a Spring for Scala is going to be built on top of ZIO, but it's not going to be ZIO in particular. But still, having the sort of Spring level of tooling, I think would be amazing, and would also open the floodgates for just new levels of developers. Like, imagine someone who comes to Scala and in week 2, they're already building applications that have all the benefits of modern functional effect systems. So they're asynchronous, they're safely concurrent, they don't leak resources, they have metrics and monitoring and tracing, all that stuff built in. Imagine that level of productivity for someone who's new to Scala. Right now, you can't do that. I mean, there's no way that you could even hope to do that, because the ecosystem is so fragmented. There's so many different styles of using software, and Play, the only thing that sort of came close to that level of productivity, went off and took a side turn and is not really all that relevant anymore. It's not innovating as it once was. So I think we absolutely need that. It's not going to be ZIO per se, but it will probably be built on ZIO.
I see. And we have another question: why ZIO use so much allocation to handle pure result? And I want to use this question as a maybe as a starting point to a wider question, which I have, how do you measure currently the performance of ZIO?
Yeah, so ZIO, because it is based on pure FP, ZIO effects are immutable, and that imposes certain limitations on how much heap allocation is going to happen in a ZIO application. And there's not really ways to circumvent that. At the end of the day, any approach to building applications that's based on pure functional programming is going to impose significant heap churn. That's just the nature of the game. What you can do is you can contain it, and you can build parts of your applications that are lower level than ZIO, but that can be wrapped up into ZIO. An example is ZIO Stream uses chunks, which are arrays of primitives, in order to handle streaming data. So ZIO has built in it several different sort of subdomains where performance has been optimized to minimize heap allocation. But at the end of the day, at the level of a ZIO effect, when you're mapping over a ZIO effect, or you're flat mapping over it, or you're timing it out, you're always creating new effects based on the old ones, just like with Scala collections. And there's a limit to, you just can't get away from that. Now, that said, JVMs are getting better and better all the time at optimizing for that. Graal VM is faster, basically 20 to 30% faster. ZIO applications get 20 to 30% faster on Graal. So there's hope that allocation is not going to be a bottleneck, but also I think merely architecting your applications in a way that pushes low-level stuff into a subdomain that is then wrapped in ZIO is a very viable strategy for achieving high performance. ZIO itself, it's still reasonably high performant within the class of functional effect systems. But that said, we've added some features that like execution tracing, which is super helpful. When you go to ship code, you want to know exactly what's going on, and execution tracing helps you do that. It slows things down by about a factor of 2. So it makes in purely synthetic benchmarks. So this is not real world application. Your real world application will not notice such a hit, most likely. It'll barely notice it, but it does slow down things by a factor of 2 in synthetic benchmarks. You can turn that off if you want. And I think after ZIO 1.0 gets out the door, we'll return and spend more time optimizing performance. But already we've got a hand optimized ring buffer. We've got state-of-the-art techniques being used in ZIO software transactional memory. We've got a lot of sort of very deep technology here that's designed to make this as fast as possible, because we know the only way this is going to be adopted by big companies is if they can use it without having to seriously think about the performance overhead. We don't have to be the fastest thing in the world, but we've got to be fast enough to not be, for there to be no excuses not to use it.
I see. Okay, thanks, John, for answering all the questions from the community.
Absolutely.
I believe that if anyone has more questions later, can reach out to the ZIO Discord, different channels, and go there, ask specific questions. The community is very welcoming, as John said. I see that we have already crossed the 1 hour of this conversation. So I would like to thank you, John, for your time. I know you are a very busy person, and it's currently 2 p.m. on the East Coast where you are, so you probably have more plans now. So we won't take more of your time. Thanks again for coming to our Tech Talk. I would
Absolutely.
just add that if anyone wants to find more about the ventures of John and ZIO, you should probably Google SciVerage, and from that you will get all the resources that you need. Or are there any websites or resources that you want to point people to?
Scala Times for keeping up with what's going on in the Scala community, and ZIO.dev for keeping an eye on. We have a blog up there. I don't think we have any blog posts, or maybe we have one blog post. But ZIO officially has a blog now. The ZIO newsletter, which is put together by Pierre, Ghost Dog PR, as you might know him. That's an amazing resource that comes out every 2 weeks and lists what's going on in the ZIO community. And then ZIO Reddit is a good place to keep an eye on new libraries that are coming out, and also some of the blog posts that are coming out, and Scala conference videos. So if you want one place, one-stop shop for all the Scala conference videos coming out, that's a really good subreddit to go to. Awesome.
Thanks again, John. Thanks for coming to
Absolutely.
the Tech Talk.
Thank you so much.
Thank you. This Tech Talk is brought to you by Software Mill, where I'm happy
Yay.
to be working since 7 years already. But the company is now 10 years old. This is our 10th anniversary this year. That's why we are doing all kinds of interesting additional events like these Tech Talks. And if you're interested in more Scala and functional programming, you should go to scala-conf.com. It's our conference that will be held at 15th of May. So very soon, you can see also our talks from previous conferences on YouTube. And as John mentioned, I recommend you to follow Scala Times. It's our newsletter that I'm actually the editor of. So go to scalatimes.com, subscribe, and you will get all the news. No spam, no marketing spam, just pure meat and news from the Scala world. Thanks again, John, for your time. I hope you, ZIO, will run the world soon, because I'm also privately very excited about it. And see you online.
See you online. Take care. Bye-bye.
Thanks, everyone. Bye.